Hey everybody, this is Austin, otherwise known as Ninth Power on the TigSource forums. And I was asked a few weeks ago to do like a tutorial or explanation of how I'm handling, how I'm doing text boxes and speech bubbles in the game. So that's what this is. I've recorded like 3 or 4 videos already, but I wasn't really satisfied with the format. I wasn't sure if this was going to be like a tutorial or what. But I think the right idea, especially because this is on the devlog, is to do like a video devlog to explain more in depth the logic and the techniques I'm using to make it work. So if you're looking for a tutorial, this should still be able to teach you everything you need to know to implement it in your own game if you're using GameMaker. But I'm going to go a little more in depth and talk a little bit about data structures and talk about the logic behind how I'm really doing it, instead of just showing you how I'm doing it with the scripts and not telling you what the scripts are doing. But let's go ahead and take a look at what it looks like so you can kind of get a view of where we're going. Kiki is the character on the left, and Cap is the character on the right. So if you press K, then you'll see the text box will appear on the bottom. This is like a view-based or RPG style text box. This is more of a basic style. All it can really do is do different colors of text, and it uses the draw GUI event, so it draws based on the X and Y of the view and not the X and Y in the room. I won't be talking too much about this. You can go ahead and read the scripts and figure it out. What I really want to talk about is how I've adjusted this basic style to Cap's style of speech bubble, and the main speech bubble style that I'm using in the game. So if you press space, speech bubble pops up. Some cool things it does is it separates the speaker name. It puts it in a different font and a different color. You can also use different styles of fonts, mid-text, mid-string. There's different flags and things that you can use, different symbols that represent to the draw function to change the font or change the color. You might not be able to tell, but the word "what up" and "yeah, that's right" are actually different sizes. They're actually different fonts. It's just they're different fonts according to GameMaker, but they're not different fonts in reality. I've just made them the same font in a different size. But you can even use different styles of fonts mid-text. This speech bubble also has built-in text wrapping, so it will wrap the text based on the size of your sprite, which is really, really handy. I just implemented that a few days ago. Without that, you have to, all the dialogue in your game, you have to try it out in game and figure out where you're going to put a new line character depending on the size of your words. But with built-in text wrapping, which I'll talk about later, it just makes it so much simpler. As well, there's this advanced dialogue sprite. This can be any sprite at all, as well as the speech bubble itself can be any sprite you want. Excuse me. And it blinks, and you can change the rate at which it blinks, which would be important for like if you have a different frame rate. This is running at 30 frames per second. It can also do multiple sets of text. So this is one sentence. If you press enter, I can do another sentence. Yes, I can even do multiple messages. Last thing I didn't talk about, I'll just say real quick. Well, 2 things. Because this is a different font, a different size, the built-in text wrapping will also adjust for this different, I call it important font in the draw function and in the text wrap adjust script. Because the way that we're drawing onto the screen, onto this speech bubble, is not based on the size of the, it's not based on like the position of the letter so much as it is the length, the width of the letter in pixels. There's built-in functions that you can pass a string, and GameMaker will decide based on the current font you have it set to how many pixels that will be. And so yeah, it's really intuitive. It can work with different styles of fonts. Let's go ahead and take a look at what it does. Oh, last thing, you can also press enter. You can press the advanced dialog button to skip to the end. That's built in as well, so you don't have to wait for all that text to render. Okay, so let's take a look at how it works. The there's a few scripts that I've taken from someone else's work. Like not all of these scripts are made 100% by me. If we go ahead and take a look, this user on the GameMaker forums, his name is Flying Penguin. He's built a few of the scripts that I've used. There's a couple of them that I've adjusted and modified to make them more customizable, so that you can use speech bubbles and different different fonts and important fonts mid-text. So most of it is based off of his work already. His scripts are message init, message add old. I added the old because it used to be message add, but I've adjusted message add to have a lot more functionality. So message init, message add old, is message, message read, message remove, and message draw. Those are the functions that you would just use to do the RPG style text box. But if you want to do more customization like I'm doing, I've added in message draw extended. Text wrap adjust I think is actually based off of his as well, but I've adjusted it to work with different sizes and different styles of fonts mid string. So yeah, it's kind of mostly him, and I've just made up a few things along the way. So I'm not as smart as I probably make myself out to be, but yeah, there's some really cool functionality in here. To understand what's happening and how it works, I need to talk a little bit about data structures and how they work. So let's look at the documentation. If you just type into the index search bar, you type in data structures, you'll pull up this page. And there's 6 built-in data structures that GameMaker has. These are common data structures used elsewhere. I know that like stacks and queues are used in database structure, like for websites. So they're really useful. I'll talk most in depth about stacks and queues. I haven't used lists or maps. A priority queue is the same thing as a queue, except you can set priorities for different things you're putting in the queue. So like in a dialogue tree, you could say that if some event has happened, then this string, this piece of text, now has more priority than it normally would, and it would show up differently. Grids can be used to divide the room in a X by Y grid for like A-star pathfinding if you're doing like an RTS, or even like an action RPG if it's top down. I think there's some pretty good tutorials about grids if you want to learn that kind of using grids for pathfinding. But these are super useful things that make, I mean, you could do all the functionality that these data structures have. You could make it up on your own, but it's just way more work than you want to do. So getting to know these data structures is really an advantage to you in learning GameMaker. Excuse me. So let's talk about stacks and queues. Queues are the main data structure, or are these data structure we're using to do this message, this text bubble system. I made a little animation to kind of show you how these two differ. A stack has the logic first and last out. So like if you're stacking boxes, the first box you put on the floor is going to be the last box you take off of the floor. So like for a message system, you would have to like add in backwards the text that you want to appear. It's much more logical to do a speech system with queues, where the first person in, the first thing into your queue is the first thing out. So like getting food at a restaurant, the first person in the door is the first person to order their food. The last person in is the last person to order their food. So as we add messages, as we add text into our queue, the way that we add it is the way that it's going to be rendered. So let's go ahead and let's go inside each of these scripts and show what they do. Message init is going to just initialize the message data structure. We create a variable message and position and set message equal to DSQ create. This is a built-in, one of those built-in functions for GameMaker. So essentially, before we go on, essentially what I and this other user have made is essentially the message title is just a pseudonym for a queue. So we're just using the word message to symbolize that we're doing a queue that's handling messages. A queue could handle it could handle people, it could handle variables, it could handle anything. That's what's super, super nice about it, is it's very versatile. So message init, it creates the data structure, sets the position which will be used to render each letter on the screen. I'm going to skip message add old. Again, I'm going to talk more about the speech bubble system. Message add is used to add strings to the queue. So the first argument that you take, or the argument that you take, is the string. I'll show you in the object how that works. So cap, she's using the speech bubble. When I press space, I'm creating the text box, and I'll talk more about this logic, but just about message add, we just pass in the string that we want to use. You can see that I also put in the speaker name. I'm using this I forget what this is called, divider, to signify that what up would be a different type of font. You just pass in the string, and this is where the adjustment for the text wrapping happens. The first thing it does is to measure how long the string is going to be, you don't want to measure the string with the speaker name, because it's going to separate the speaker name. So if you didn't, then however long your speaker name is how far off the text wrapping is going to be. And you don't want that. You want to measure the words and not the speaker name. If there is no speaker name, I don't think it will... yeah, if there is no speaker name, then it won't cut out anything. But if you want a speaker name, it will cut that out. That's what this text does. And then text wrap adjust is going to add new lines into your string where they should be based on the size, the width of your speech bubble. So you pass in the string that you want to adjust, and you pass in the sprite that you're going to put text onto. Let's go ahead and look at text wrap adjust. So it inserts new lines into a given string until its draw width is as specified. Argument 0 is the string to wrap. Argument 1 is the width in pixels to fit it to. So you can see that I don't just pass in the sprite, I pass in the sprite as a function of sprite get width. Sprite get width is a built-in GameMaker function. It just gets the width in pixels of a sprite. So what this does is it's going to add in new lines. And this is pretty much what Flying Penguin has put up, except I've adjusted it to work with the different styles of fonts, the flag, this divider flag that you can use to make text a different style. Because otherwise, what was happening is that if you don't do that, then it will just adjust. It'll put in new lines based on the width of your string based on just a default font. So you have to set the font before it checks how long it's going to be. That's really important. And I was having some issues at first because it would, like, when I first ran the text box, when I first ran this, like, I would press space, it would work properly. I mean, it would look the way I want it to, but then in the draw function, the font that it's supposed to be would be adjusted. And then when I press space again, the new line would be in a different place. So all I've done is I've made it possible for different styles of fonts to be used. So what this is doing is it's saying that loop through the string until a space is found. Before it checks for a space, though, it's going to check for this important text flag. So it's going to go through the string. It's going to see if there are. It's going to see if the current position, which is what's called pivot, in the string is this character. If it is this character, it's going to multiply important font by -1. And then it's going to adjust the font based on what the value of important font is, because we want to measure the length of each letter based on what font it's actually going to show up to be. If we didn't do this, then it would just measure the whole string as this normal text. My normal text is font hunter, and that would make the text wrapping off a little bit and drive you crazy, like it drives me crazy. So after we adjust for if the current position is this special font, then we're going to set the font based on what the value of important font is. So if important font is 1, it's going to set the font as normal text. If it's if this is true, if it is a important text flag, then it's going to set the font as important text. And these two variables are just set to the fonts that you have for normal text and important text. Then it's going to go through the string, look for a space, and if that space is too far to the right, it's too far, it's past the width of your sprite, then it's going to add in a new line. That's all that this code is saying, is if it finds a space and that position of that space in pixels is farther than the width of the sprite, we're going to replace that space with a new line. And then you increase the, for each go through of this loop, you're going to increase the pivot position. And you're going to return this new string with the text wrapping automatically adjusted. Okay, so like I said, we separate the speaker name from this text that we're adjusting. Then we pass back this string with the new line characters in the proper place, and then we put that string plus the speaker name into the queue. And when we put it into the queue, into this message queue, you remember that we made that global variable message. This will put it into the queue, and then our draw function will still draw the speaker name, but the new lines will be based off the string without the speaker name, if that makes sense. So that's how message add works. You're just, to overview, you're just adding your string to the queue with the automatic text wrapping. isMessage is going to return whether the queue is empty. So if the queue is not empty, it will return true, I think. If it's not empty, it will return true. Yes. And if it is empty, yeah, because DSQ empty returns true if it is empty, and it returns false if it isn't empty. So if it isn't empty, we're going to change the false statement to a true statement with our exclamation point and return true. So if it isn't empty, if there is a message, then it will return true. If there isn't a message, it will return false. And we use this to determine when to be done rendering the speech bubble, to be done to remove the current dialogue from the queue and go to the next queue, the next item in the queue. Message read just reads the current, the next spot in the queue. It just returns that string. So it returns the first string in the message queue. Message remove removes the first message in the queue, the current message. So after we're done rendering it, we want to use message remove to take that out of the queue. Otherwise, the speech bubble will just render that string forever. And it returns the position of rendering the text back to 0 so that we can place the strings in the same place every time. I'm not going to go super heavily into message draw extended. I'll just skip over some things and just say what they do, and not so much in depth of what exactly the variables and functions are doing. Otherwise, this video will be like an hour long. But essentially, this is an extended version of message draw. It takes extra arguments to specify unique speech bubbles, a continue message sprite, and other features. It also adds functionality for using different font styles within the same speech bubble. So these are the arguments that are passed in, and I'll bring up how I'm passing, the example from Cap's. Sorry, that's not right. Let's go to the well, I guess she's part of it as well. So let's go to her object, space event, and then let's go to the text box. I think it might be useful now if I go over a little bit the logic of how. So we've gone over how these scripts, what these scripts do. Let's talk about the logic of how they're used, and then I'll show you an example of how that's used. I think that's the best thing to do. So I made another little graphic to explain how the message logic works. So how the logic behind using these scripts work. First thing you have is you have an object event. In Cap's case, it's the space event when I press space. You could have it be like if your character is touching an NPC and you press the action button, just some event. And when you in the text, in the code of that event, you're going to do three things. You're going to create a text box object, and that text box object in its create event will automatically initialize your message queue. It'll initialize that system, that data structure. Then you're going to decide where the text is going to be placed. Where the speech bubble is going to be placed. And where the speech bubble is going to be placed is going to automatically adjust where the text is going to be placed. And I'll show you that in a second. And then you're going to add messages. You're going to add whatever your strings are going to be in the order that you want them to appear. So what that looks like is this. In the space event, when we press space for Cap, it's going to create a text box object and set it to text box. Then we're going to adjust the speech bubble X and Y coordinates of this specific object. This should say decide, I guess text placement is the same, but it should say decide speech bubble placement. We're going to place the bubble based on the position of this character. That's useful because if you try to define where all these speech bubbles are in your room could be huge and it will take you forever to place them correctly. But if you just find some useful like diagonal direction, diagonal position that the speech bubble should be from a character, that will go a long way. So we're basing it off the X and Y of Cap, and we're just adjusting it by some arbitrary number that makes it look good. Then we're adding our messages to the queue. After you do that in the object event, then the text box the text box object will handle the drawing of the text in the message queue. Let's take a look at what that looks like. And there's two different types of text box objects. There's the text box VB, that's the view-based one, and then there's just basic text box, which is what is used for the speech bubble system. In the create event, it initializes the message queue. It just initializes these values, which we changed here: speech bubble X, speech bubble X, speech bubble Y, speech bubble Y. And then these variables are just used to determine the blink rate of your continue message sprite. Then in the draw event, it's going to check if there are messages in your queue, and if there are messages, it's going to draw that next message. It's going to draw the current message. So let's look at the logic first, then I'll show you the arguments. So how the text object works is you have this message queue that you've created and you've added messages to. And the draw event is going to draw that message. It's going to draw every letter in that message. Then that message queue is going to be passed to the enter event. Press enter, or press action, whatever you have the action based map to in your game. And when it goes to the enter event, it can do two things. If you're pressing enter, if you're not at the end of the message, it will jump to the end, which you saw me do in the beginning. If it is at the end of the message, then it's going to remove the current message from the queue. So if there is a message and the position is less than the length of the current message, then set the position to that length, to the end. And that's how you skip to the end of the text. If there is a message and we are at the end of the message, then we want to remove that message. We also want to check if there are no more messages at all, we want to destroy this instance of the text box to remove it from memory. And this else statement is just kind of a fail-safe for this. Let's go ahead and look at how we pass variables into the message draw function. Let's go ahead and put these two like this. And this one like this. Okay, so this is what I'm actually passing in, and this is what they mean. So I'm going to pass in the sprite to serve as a speech bubble, and this is the name of my sprite. I'm going to pass in the X and Y coordinate in the room that I want the speech bubble to appear, and you can remember that I based speech bubble X and speech bubble Y on the position of the character that's causing the text to appear. Then the X and Y coordinate to begin the text at. So this is the X and Y coordinate of the actual text of the message to begin at. So I made it, yeah, sorry, that's this one and this one. So we've got that one, and then these two. Right. So I'm causing the text to appear, and this is the, yeah, right, okay, sorry, I'm confused because the logic is kind of backwards. Right, so these two variables are the variables for the actual text of the message, and then these two variables are the X and Y for the text of the speaker name. So you can see that I'm basing it again off of the speech bubble X just to make things simpler. And I'm subtracting this much from the X coordinate and this much from the Y coordinate. I'm subtracting around the same amount of the text from the speaker name X, but I'm subtracting more from the speaker name Y than the text Y, because I want the speaker name to appear in my speech bubble higher than the beginning of the actual text. And then the last three have to do with the continue sprite. So we're going to actually pass in the continue sprite we want to use, and we're going to pass in the X and Y of where we want it to appear, the X coordinate and Y coordinate of the continue sprite. And then it's going to render the text of the current message. Let's make this big. This is the explanation of those variables, and this is putting these arguments to variables we're going to use within the speech bubble. We're going to initialize some variables that are going to help us render the text properly on the screen based on the position and based on the style of font. As you saw with text wrap adjust, I'm doing the same thing here with the important font, because when the important font is on, I want to change the font and I want to adjust the length of the rendering based on the length of each letter of the font. Important offset represents the number of pixels, and the Y coordinate important text should be offset by. It helps if your important text is a larger size and you still want the bottom line to line up with the smaller. So if you don't have, you'll adjust this based on the style of your important font. But if you don't have this, then the text, the Y value of your important text will be the same as the Y value of your normal text. And if you have a bigger text, then it will be like, it won't be on the same line, like the important text will be down a bit. So I'm just using this to adjust the formatting to make it look right. And you'll have to adjust this value based on the important text font that you're using. I guess I could have made this, yeah, I could have adjusted this based on using like string get height. I could have done that, but I didn't. So if you want to adjust that to make it more logical, I guess you can do that. Here I'm defining some colors, some specific colors that I want to use. The message draw function, the message draw sprite that Flying Penguin uses, you can go down here. This is from his function where he defines down to here some basic colors that you'd want to use. You can see that C red, anything with C underscore and then a name is a built-in color for GameMaker. But you can see for like the blue, I've made my own blue. His blue is, you know, 00255 in RGB. But I want to make my own blue, so I made that here, and then I just set this value inside of the draw set color built-in function. So I'm making my own colors. I want to draw the speech bubble based on the X and Y that I've passed in, and then I want to read the current message into the MSG variable, and this MSG variable is going to use to render each letter on the screen. This group of text, this group of code right here is just separating the speaker name. If you want to go through that, you can. Then we're going to draw the speaker name. Again, I set my own font. If you want to use the same font, then just comment this out. But I want to use my own font. You can set the color and then actually draw the text. And then you can see that I changed the draw color. Then right in the message, it sets it back to black. And again, the black I want to use was different than the black that Flying Penguin used. But you can just, this can just be C black if you wanted it to, the built-in black. But I wanted my own black. Then this repeat loop is what actually draws each letter on the screen. Repeat is a function for GameMaker that just goes through. It just loops through a set of code as many times as you put into these parentheses. So what we're actually doing is we're looping as many times as there are characters. Because right now, like if this is the beginning of the message, POS equals 0 or equals 1. So we're just going to loop once. So we're just going to render one letter on the screen. But then we're going to increase POS down here. If I can find it. Yeah, POS plus equals 1. We're going to increase it by 1. So now we're going to render 2 letters, then 3 letters, and so on. And that's kind of how you get the typewriter effect. So we're going to pass in the current character. If the character is not if the character is the percent sign, this is the flag for changing the color. So I didn't do that with Cap, but you can see that here with Kiki. You can see right here is you have the percent sign, and then you have a letter that represents the color that you want to change it to. And K, the letter K, is the default for black. So let's show that back in here. So we're going to change the color, and then we put a letter associated with that color. So B was blue, excuse me, the default K is black. And if you don't put anything, this switch statement will default it back to black. So we're going to check to see if we want to change the color. If color change equals true, we're going to skip the rest of this because this is all putting text on the screen. We don't want to put this letter on the screen. We don't want to put this percent sign on the screen. So we go to the next letter, and if the letter if color change is on, which it was, then we check for the letter and it changes the color. If you put the important font flag, which is this divider symbol, it's shift backslash, then we're going to change the value of important font, and then we're going to, does it do it there? It doesn't do it there. Where did I put it? Oh, it checks it down here. So we change important font essentially to be true, even though it's negative. Then we come around, and if the next character isn't a new line character, then we're going to render the text on the screen. And we're going to render the text based on the value of important font. If important font is less than 1, which is what the flag changes it to, then we're going to set the font to our important font. And again, this can be whatever font you want, just a font that you want to use as your important font. And it will render the text and adjust the spacing based on the width of the character in this specific font. It's really, really nice. If you're not doing important font, it'll just do the basic font and render it on the screen based on the basic font. If none of these are true, you're not changing the color, you're not doing important font, then what it means is that the character is a new line character, which is the pound symbol, and we're going to we're going to skip a line. We're going to add the height of the current font's character and add 10. This is again an arbitrary value to use to make the formatting correct, and then set the position in pixels back to 0, and then increase the position of the letter. Then this text down here has to do with, I'm going to skip this. You can read that if you want. It's not really essential. It's more like a failsafe. But this text down here, this code down here, is what does the flashing of the continue sprite speech bubble. So I think I've gone through everything. Let's go ahead and take a look one more time at what this all does. So we're just going to do caps. So we press space, separating the speaker, different color, different font. You have important text, your own unique speech bubble, and an advanced dialog button. And if you press the advanced dialog button before the text is done, it'll jump to the end. I hope that I've covered everything. If you have any questions, please feel free to ask. I'd love to help anybody who needs any help learning about data structures, or maybe modifying this to do your own thing. I'm going to put this project and the link to Flying Penguin's code in the description of this video, and I'll also put the link to the devlog, and if you're watching this on the devlog, you're already there. I think that's it. Thanks for watching, everybody, and I hope this helps. See ya.